Felicity, it's good to be here. I was able to attend most of yesterday, and I've been very impressed with the caliber of students and people who are involved here. It's a pleasure. I try to interact with all of you if possible, just to know you and see what we can talk about. Just to put a few things in context, this Rapid Response System is a group that Northrop set up, and its purpose is to act like New Space. You know, so we do CubeSats, and we did the LCROSS mission, as we said. My personal role on that was, NASA said, this is what we want to do. We want to figure out where there's water. How are we going to do it? And so I sat down, and it's embarrassingly fast, because we'd already been working on concepts to do that. But in about 20 minutes, had defined the whole mission concept using the Centaur upper stage. So I then put together the team, and we won it. After we were executing it with Ames, had a great relationship. I handed it off to someone who was able to figure out how do you do things for half the price of what it normally costs you. And we're trying to make that a normal process. Now, the topic here, I guess there's a typo in the first line, because it says, what could space be like in 2030? And that's a question. So there should be a question mark at it. So before I get going, I just wanted to ask, what do you guys think 2030 will be like? That's the span between now and basically your lifespan, looking forward. So in space and not in space, what do you think? What are some ideas?
Man on Mars.
Man on Mars, okay, there's a good one. What else? Let's hear some other ideas, get some involvement here before I get going.
Asteroid mining.
Asteroid mining, okay. That's a good one too. What? Which one? Okay, the space debris going out of control and bad things happening and basically closing off space. Space colony on the moon. Okay.
Democrat-controlled Congress.
Is that a prediction or a hope? But anyway, we'll let that sit there. Two more ideas. Space colony where?
Out in free space.
Okay. The Ames director recently announced that an initiative that they're doing with DARPA is looking for $1 million, looking at a spacecraft that would be a 100-year mission to go to Mars one way. And they would have 100 years to establish a footprint on Mars and never come back. And so anyway, probably not by 2030. So one more idea and then we'll get into the charts.
ISU in orbit.
ISU.
In orbit.
Okay, there you go. That was the third phase. I saw a hand over here, so we'll take that idea over here. Ah, there you go. Okay, so some of the things we saw yesterday. All right, well, here's how I've parsed this out. You have to know that of all the talks you're going to hear, this one has the largest error bars. Because no one's going to prove me wrong today, and who knows? And whatever we say here today is going to be wrong in some aspect. So I've introduced our second. I have two charts here on just who we are. I then look at the future. You know, what is it to predict the future? What are the issues that we've seen in the past when people look at the future? Then look at some of the macro trends and pressures that are going to affect not only the future immediately, but you getting a job next year or us in industry. You know, there's some very significant things happening right now. And then I have a series of mission concepts that we look at. What are different agencies and commercial kind of doing? Some of them you're going to be very familiar with, and I kind of go over them very quickly. And then finally, we could take the whole time in looking at what could companies do and what could you do to be ready for 2030 personally. And so I present a strategy of what I would recommend, what I tell anybody that I'm mentoring in our company. That when you come into the company, do this. Now, you're going to tailor it for your personal interests, but we could actually spend the whole time. Okay, so Northrop Grumman, we're located in Redondo Beach, California. We used to be Space Technology. We got merged with the group that also does the B-2 bombers and the Global Hawks, the UAVs, so that now we have an aerospace focus. We're currently the prime contractor on JWST, the next Hubble, if you will. We did LCROSS, as we said. We do DSP, a whole series for 25 years of early warning satellites. There's a whole bunch of issues going on in our weather satellites at the moment. We also work with Lockheed, our friends, on advanced EHF. And then we have a big chunk here, and we build eagles, and that's all we're going to say about it. LCROSS is a mission with impact. You've already heard a lot about that. I've explained my role in it. This has been one of the highlights of my career, and it's been just great to see it have such a big impact, not only on the nation, but on the company and on my environment. So the future, let's get into the second topic. And the future is hard to predict. It will be more like the present, only different. So the issues are, how different will it be? Now, when people do movies about the future, they don't want to change more than 30% of the life situation. That's a Spielberg rule. Otherwise, people lose lock and it doesn't relate to them. So you can only change certain things. Now you notice that 2001 looks like something that could be feasible. Well, what was wrong with that movie? Okay, the monolith, it assumes some extraterrestrial. What else is wrong with it without even watching the movie that you can kind of discern? Size of the computer, the personality. What I'm referring to is the title. 2001, it was conceived in a time when from Sputnik we had gone to the moon in not more than, you go back 10 years, 12 years. And so that rate of change, you extrapolate that from 1968 to the year 2000, it looks feasible. But the problem was we didn't keep on that track. We kind of actually nosed down. So I have some charts on that. So it's hard to know. You can see technically something that's going to happen, but there's all kinds of other issues, political issues that get into it. So current change rate, at least for me, is a little bit uncomfortable. Things are changing in my job, things are changing with my kids. I have 4 teenagers. They have iPods, they have all kinds of things that I didn't have, and they're texting, and I'm watching their brains are working differently, and they have a hard time focusing on some things just because they're always being interrupted. So, in personal life, in the national setting, a lot of things are changing. Now, differences over time are huge. If you make a 9-degree shift, that's not a big change. But you do that for 20 years, you're going the exact opposite direction. That's a huge change. That's as big a change as you can get. And the other issue is that change events are nonlinear. 9/11 changed certain things, and we probably are never going back. And they changed all at once. But one key thing to focus on is that engineering is focused on promoting and controlling change. So change is our friend if you're in engineering. I'm going to show a chart about 2 bad periods in the industry's short history. And both of those were times where the nation throttled back and said, we don't need any more change, we're going to save money. And those actually were the bad times. So change, from an engineering perspective, is a good thing. Now, I looked at a series of books, all that related to 2030, basically. And there was one common thing. Some of them were more optimistic. Some of them were downright spooky. When they put nuclear explosions on the cover, it's kind of a spooky presentation. But they all were calling for purposeful change. Let's plan it, let's execute it, let's do it. And don't just let what's going to happen in an uncontrolled way. So they did it some by the carrot, good things, and some by the stick. So that's what we want to think. How can we personally, and how can we as companies, control the change or influence it? Surf it is what I'm going to call as a title here in coming up. Another thing is that just because it's technically possible, just because you could have the university in orbit, doesn't mean you will, or you will at any particular date. It's probably a good thing to say that, a reasonable thing to say that eventually it will happen. But it could happen in 10 years, 100 years, or 1,000 years, depending on which way politics goes. It's said that if the Muslim revolution didn't come through Saudi Arabia would have got to the moon 500 years ago. But that had a huge impact on how they view change in technology. So what is the key? Is there's a huge set, a complex set of self-interests that come into play. And those are both in the government and they're also in the marketplace with consumers. And so marketeers and people who look have to take the technology that's possible and filter it through what will go through Congress, what will the administration see as being in their benefit. You know, Kennedy made the decision to go to the moon because he wanted a certain impact on the nation, not because he wanted to actually touch the moon. It was the nation he was trying to influence. So here's a picture, you know, and you can see that the hills are there, but it's very hard to know whether they're 5 miles, 10 miles, or 100 miles. So just because it's technically possible doesn't mean you know when it will happen. And to illustrate that, here's a chart. And there was a series of 3 videos, and these came out. We were also the agent that was doing the contractor that was doing the Prometheus mission. And Prometheus was a huge nuclear-powered system to go out to the outer planets. Well, in timing with that, Disney released these 3 videos. And Disney made them between 1955 and 59, and he collaborated with the best mind he could, you know, Wernher von Braun. And the 3 missions were man in space, showing just orbital operations, flight to the moon, landing there, getting there, coming back, and Mars and beyond, and that's this image. And what they came up with is astounding, because man in space was done before Sputnik had even won. And all of these were finished before man had even orbited or gone into space. So here they had tremendous insight. This is a nuclear-powered electric propulsion system that was conceived and presented and is totally feasible. It used cesium instead of xenon, but this could be done, and it was right-sized, and it was a mission to go to Mars or anywhere in the outer solar field, outer planets. So it had such an impact that the U.S. President Dwight Eisenhower requested a copy of Man in Space for the military top brass who were dismissing space travel as Buck Rogers science fiction. So here you have something that influenced the nation and was also way ahead of its time, and it couldn't tell when this would happen. Now, political will happens when people align. If you never get people to align, nothing will happen. So here you have some wind patterns, and these aren't random. You know, the sum of random vectors is 0. That's the drunk who staggers away from the pole. Eventually, the most logical place or probable place for him to come back is to the pole. You won't get anywhere. So critical alignment results in action. So here you have a wind pattern, and if the nation, if this represented the political vectors, we would be making great progress that way. All right? And here are 3 examples of how you can do things when you have to do them and you're aligned. The United States was concerned that we were going to be annihilated by a Russian first strike system. And in 3 years from the word go, there were Polaris nuclear subs with missiles in them, all that worked and could hit the target in 3 years. That is unbelievably fast. When you have to do it, you do it. The same is true. Apollo, 8 years from go to landing. Total alignment. It had a huge impact on the nation, and everybody felt it was a national imperative. It was our way of fighting the Russians instead of blowing them to smithereens. You know, it was a safe, and it was us showing that our way of life, our way of thinking, freedom was better than the other alternative. So we were showing the world and ourselves the rightness of our cause and our position. So change requires 4 existence equations. People make a lot of mistakes. You know, students will make a mistake because they focus right down here, and I put it at the bottom. What is technically possible? There's 3 other issues that have to be dealt with, all of which deal with the political side. The top one is you have to align something. You have to satisfy all the political levels for a concept to be funded or happen. If you're doing a NASA mission, you have to satisfy the administration's budget. You have to get congressional support. Headquarters has to think it's a good idea. You have to align with Center and their politics and have them as a teammate. You have to then align with your corporation. Your corporation has to want to do it. See that it's in their interest. They're going to actually make money and not lose their shirt. And you have to align with the university if that's true. All of those things have to line up, and when you put those grids over it, you have to see light come through that. If you don't, any one of those levels can kill your idea, kill your program. Secondly, and this filters back into the political, is you have to meet the cost requirements. An idea isn't a good one unless it's affordable. And in this next decade, that is going to be almost everything. It used to be you had to do the requirements, and now they're saying, well, you do most of the requirements. 80% is a really good solution. 70% will go. So cost is the key requirement now, and the others are negotiable. And it's not just the total, it's the yearly funding. 1 year that next down can mess you up. The third one is programmatic. You actually have to be able to make it. You have to have a plan. You have to show that you can do this with low risk to them, or you won't get their nod at the top. So these are 4 simultaneous equations, and if you can satisfy them all, something will happen. And the bottom line behind everything, all the political side here, is people want to work with people they trust. Basically, they want to work with friends. They want to work with people who they know won't take their career down and sabotage their whole thing. So the corollary is build trust in all key relationships. When you go into a company, if you're there as an intern, get to know the people and do everything you can to make them successful. Get to know what their needs are, get to know how they are evaluated, study the political situation, and do whatever it takes. I remember staying up till 2 in the morning to make sure deliverables were in there in my first assignment, and doing all-nighter since, but that's the key. So, 1999 to 2010, what has changed? So let's say, it would be reasonable to say the amount of change we've seen there is about the amount of change we'll see in the next 20 years. And maybe more, but at least it kind of balances. 1990, Hubble was launched. So all those pictures of the last 20 years, and the first ones didn't work, so there's missions to fix it. There is an Apple in 1990. And there is Steve Jobs. He was actually young then. In fact, I look more like you than I do now, I look like myself. Here was the cell phone in 1990. Windows 3 was released, and it only would lock up every hour, not every 10 minutes. The Soviet Union and Cold War were still in place. It was a two-pole world that we were living in. East and West Germany started 1990 as separate and finished united. And Iraq invaded Kuwait and started this whole thing, that we've been kind of dealing with over the last 1 year. So there's a lot, is that a lot of change? What do you think? It's a good amount. So a lot's changed. Now I'm going to show an example. This is someone who worked for Northrop. I worked for Northrop Grumman, so he was born in 1894. That was 9 years after the car was first prototyped and the motorcycle was first prototyped, 1885. He worked in Nebraska with a plow. He took the motorcycle during World War I and would drive it full bore, complete lights out, with no moon, to carry messages across enemy lines, and Germans would all shoot at the sound and never hit him. He became an engineer, spent 20 years sharing technology over there, started a school, engineering school there, and drilled 440 water wells. And then he drove from Calcutta to Los Angeles in that car, which is a 32 Ford, right through Afghanistan, Iraq, and everything. Survived the Great Depression and started working for Northrop. And so this is my grandfather, he saw a huge amount, and he ended up working with automobiles. He had the Ford dealership which didn't really exist as a prototype when he was born. He ended up working with airplanes, which also didn't exist when he was born. So all the big areas that he got involved with didn't even exist when he started. And our time period is compressing. So you are likely going to be doing that. You're going to be working in areas that don't even exist. So here is a short kind of my summary of what's happened since space became industry. What are the issues? You know, in the 50s, the issue was making a launch vehicle work. You know, I don't know if you've seen any of the movies, but vehicle after vehicle, you know, goes up 10 feet and collapses and crashes. That was, you know, that's where the phrase, yeah, it's not rocket science came from. Because rocket science was seen as very difficult. You know, now it's fairly easy. And the issue with spacecraft, the issue with spacecraft is just getting to orbit. Then the issue in the 60s was making a spacecraft so it would work more than a few days, and making a launch vehicle so it was reliable. Then in the 70s, people wanted to do real missions with it, so they increased capabilities. They wanted lifetime for the spacecraft, you know, more mass to orbit. The shuttle was everything in the 80s, and of course Challenger came along and changed that. So we kind of made, we fell back from yellow to red. Then the EELV came in the 1990s and had a stellar work. Low cost, faster, better, cheaper was the issue, because here we had this downturn after Apollo, and again the end of Cold War reduced budgets. So every mission had to be as cheap as it could be. And during these two compressions, if you were graduating in these two zones, you had problems. You became a computer scientist at IBM or something. But you didn't go into industry. So there was 10 years at TRW where the company hired 0 people. The amount of employment went down by 1 because 1 of the 1,000 employees died. But everybody who started that 10-year period was there when it ended. So that is an important thing to realize. And when I went into engineering, it was bad. And it ended up being good because I caught this wave right here, and that was very helpful. Here's what's been happening over this period, the last 20 years. This is total engineering employment. The purple here is guided missiles, space vehicles, and parts. And it's a factor of 2 reduction from 1990 to 2009. So it's been relatively flat over the last 10 years, but this was an ugly, ugly time in industry, just to let you know. Now, across this sequence, you've seen technology shifts. The issues down here with spacecraft were what I'll call mechanical, making mechanical systems, including propulsion, work. Then the issue, of course, the focus has been on building electrical systems to do useful missions. And more recently, we've gone digital, all digital, and now we're on the verge of having really software-defined solutions, where the hardware is so capable, it's the software that varies from mission to mission. I'm going to show a chart that's going to represent that. So what is that kind of compression? I guess I didn't really say. So out here, what's going to happen? Well, you're seeing Falcon 9, a higher capability, heavy lift launch vehicle, and production issues dominating in here. Is any of this zone red? That's the question. Okay. So in the last downturn, the United States military reduced by basically the size of the force that was in the first Gulf War. That many were let go. And they had a meeting back in Washington that was called the Last Supper, where they invited all the heads of these companies to come in. And they said, you know, spending's here, it's going here. We think you should consolidate. And so within a matter of months, all this stuff started happening. And this is only up till about 2003. So these large 4 companies, there are 2 others, were all formed out of, when I graduated, all of these various pieces. Now, what is likely? What is likely is another round of consolidation. It might not be between these big players, but it might involve a lot of the smaller players. So this is a factor. Now we get to the bad news, and then we're going to get to the good news, okay? So don't fall asleep or fry. This is a graph of the U.S. debt from 1900 to the year 2020 projection. So we're right here, somewhere right in there. And the bottom line is this is not good. Okay? Because it means, now you can say, well, you know, money has changed. Well, here it is spread out, you know, percentage of GDP. So we're about to the place where we were leveraging the nation and borrowing like crazy during World War II. So that's not good. Now Japan, there's an interesting article on October 16th in the New York Times. It was titled, "The Japanese Economic Malaise." It's worth reading on how Japan went through their bubble, and for 10 years, they have been flatlined economically. Whereas the United States has doubled its output, its GDP output. And what's happened in Japan is a thing called deflation. Well, it turns out inflation is really not that bad. It's just too much inflation. Deflation is where money gets more valuable. Now, when money gets more valuable, what do you want to do with it? You want to keep it in your pocket because it's going to be worth more next year and more after that. And when you keep it in your pocket, nobody uses it and the economy goes wrong. So that's the issue here, and that's what the United States needs to avoid. And the debt is related to it, and I'm not an economic expert, so I'm not speaking with too big of authority. The one thing that we are told over and over and over again is federal space outlays will be reduced. We are on this kind of a curve. So you had best and we had best know it. So that's one macro trend. Another macro trend is the U.S. position in the world is changing. And I'm not telling you anything you don't know here. You know, China's economic parity with the United States is supposed to occur sometime between 2015, which is like not very far away, and 2030. The best projections I could see were economic parity around 2030. So that's a big issue. That means we could be back to another kind of two-pole, two-superpower situation. And that could be good for the industry or that could be bad. It depends. Now, some of them say that by the year 2030, China could have twice the economic output of the United States. So it's unclear. But their space infrastructure is growing like crazy. They have, I've read a report on Classified that says China has 30 anti-satellite systems alone. All different types. You pick, how could you take out satellites? And they're on that list somewhere. So, but that isn't the only thing that's changing. India in 2032 is supposed to become the world's largest by population country. Now, all the news isn't good for China because they are going to have the oldest population in the world because of their one-child policy. And that's going to have ramifications. But the Chinese are basically a nation of only children. And I don't know what that means to you, but that means certain things to me. Another issue is a nuclear Iran. And what does that mean? That could bring a lot of excitement. Not a big. Okay. So what are the positive trends in industry? Well, mission requirements will continue to increase. What do I believe? I believe that there's going to be a push for persistent coverage, which means, you know, Worldview flies over, you know, every 3 days. You can get an image if you need it. When you go to Google Earth, it's on the next thing, you look at it and it's, you know, April 15th of last year. Well, persistence means you have a spacecraft that can look at every spot on the world all the time. You know, it's a LEO constellation, proliferating. So what are the risks of spacecraft? Well, predominantly lasers in LEO can kill sensors. And co-orbiting, you a CubeSat with a grenade in it and snuggle up to any satellite in GEO and go, boom, surprise! And that satellite doesn't feel very good. So we have recently been given a contract from DARPA to build an imager to sit at GEO unclassified that will be able to see planes and buildings and cars, but not people. And it's a very interesting program. So those kind of requirements are going to increase and drive new systems. The current workforce is aging. Where I come from, and a lot of other of those big companies, you see a lot of this color hair, And people aren't quite, like this, but they're getting there. And what do they need? They need, the companies, we need new blood, talent, and ideas. And there's two groups in our company that continually amaze me. And they are the oldest employees who are there. You ask them a question, and the next day you get this report that completely explains everything, and they have done it, so many times. So there's one group. The other group is the newest employees that we have, who come in and use tools that we didn't even know existed and get analyses done, and we go, wow, you're hired and you're promoted. So those two groups are great. But this is our CEO, and he looks like that. When I first met him, he had a blonde afro like this. And smart as you can find, and the nicest guy in the world, and we need more like CubeSats. They are a force to be reckoned with. And as more and more capability is built into that form factor, it doesn't only change CubeSat, it changes every other kind of satellite. Because that functionality can now be built into those. And commercial space is zooming. I mean, I think it amazes anybody who's been in industry over the length of time that we've. So these are all huge opportunities. They kind of go against those other negative trends. And they say things are different, but they aren't going to be horrible. So here's a notional space market. Now you might say this is bigger than that, but we're not going to talk about that. This is all government. This is commercial. Now a lot of this has government money behind it, but it's commercially controlled and procured and built. So what can we assume will happen over the next 20 years? And here's my conclusion, that government will be doing more in terms of requirements, but for less investment. So it's going to have to be efficient and smart. And secondly, that this sector is going to be growing, and we don't know how or significant that growth will be. It'll depend on whether you will actually get in one of these things that zooms up to up beyond the stratosphere. So there are three. I've divided it into three groups. To say, well, if we're looking at 2030 specifically, we can know a lot about it because a lot of the spacecraft we're building now will still be there in 2030. They're in production, maybe not the first one, but the third or the fourth in that series. It's going to be on orbit. It's going to be a capability. So we know that's like the anchor to the architecture. And we know that a lot of things that are being developed now, conceptually, will actually fly. Bigelow, boy, they're really going. I think they're going to have hotels in space. I'm not going to afford it, but somebody will. There'll be space tugs. There'll probably be a reusable launch vehicle. That's the next architecture that the Air Force has said it wants to use to replace the ELV. It's actually at 2030, but there'll be development work on it. You probably will have lunar ISRU, in situ resource utilization. You'll be pulling the water out of the soil, and you'll be doing it. Not just demoing it, but you'll actually be doing something. Solar sails, and the small sensors that use solar wind, and space cutters. So this type of thing, the engineering of which is not known at the present, will be a huge amount of opportunity for engineers and brain power to come and make them happen. And I'm missing the chart. And there'll be exotic things that people will be thinking about. Large platforms, solar stations. I don't think they're going to be beaming power anytime soon. but the first place you'll use large amounts of space power is in space. Laser propulsion, that's an interesting thing. Where does it fit? You don't know until you've done the quick demos and seen what its potential is. Nuclear thermal rocket, which looks very blue there, is a way to get to Mars. It's probably the only nuclear technology that's useful for humans. If you have a nuclear reactor and you crank it up, go supercritical, and you have a huge hydrogen tank, and you just open the valve, and in no time, the flux goes, it superheats that, and you get huge thrust very quickly. You can get to Mars right now. This is a fission where you have nuclear uranium pellets, and that'll probably be these things. Okay, so national economic performance and competition will drive achievement. In other words, we're going to have needs, and it'll keep you happy. Okay, a robust space recipe. So if we're going to plan now to be somebody in 2030 as a company, what should we be doing? Well, I think we should align with the low-cost launch vehicles. Falcon 9, Taurus 2, Minotaur 4. Those are going to be, unfortunately for ELB, those are going to be big things. Common robotic systems and electronics and links. You can't have everything be unique. So the capabilities on the hardware are going to grow, and they're going to become cheap enough so that you'll use it throughout your architecture, just like Verizon has put every kind of service you can think of into a phone and made a commodity of it. A solid-state redundancy to achieve long spacecraft life. If you're taking a chip and you have a small processor, well, why don't you take 20 or 50 of them? Have voting logic, put artificial intelligence into it, have it react to contingencies, and that way single event upsets or particular damage won't kill it. It'll last a long time. High volume automated robotic production will make the LEO constellations more affordable. Maybe spacecraft that are never touched by human hands, where the processes are exactly the same each time. And innovations recycled on-orbit debris. It's up there, we should use it. Why bring it all back? Just collect it and do something good with it. So a non-custom production environment, currently we build spacecraft one at a time, where you stop doing that and you start mass production like Ford did, can provide more spacecraft and services for less money. It's got to happen. So some specific things. By 2030, there should be a common robotic brain, series. Large chips, high capacity, and that smarts is used in all of these platforms, one in every car, one in your home, all the way down. Why have everything be different? As long as it's rad hard, we can fly it in space. So hardware, software redundancy, voting logic, artificial intelligence allow these systems to be super reliable and safe. So it can improve life cycle costs and performance. So there's one thing. Low-cost, long-life LEO constellations. Stack a bunch of them in, use the systems we just described, phase arrays, a large constellation. They can provide persistent comm and ISRU or intelligence surveillance. Here's a system. This has been available since 2006 so that you can get broadband in your car wherever you go. Most likely, this will be universal. You'll be connected wherever you go. Okay? Continuous monitoring and protection of natural processes. Currently, this is a one pass. This is the quad that's right over the front there. And you'll be able to access that routinely and see it. And space can be used to monitor each person's farm and fisheries and damage to forest areas, so that you're not going to be able to control human activity that's destructive to the environment with some kind of a monitoring device, some kind of a monitoring system. And so these LEOs will allow that, so that the last fish you have will not be the next fish. Next chart. Now we switch to space science. To understand the Earth, if you take a look from a science perspective, When we study the Earth, there's all these curves, and we have a single point on those. And we know if we move from that set point, something's going to change, but we don't know what, because there's so many variables. When you go to the other planets, especially the terrestrial ones, you see a completely different equation, different variables, and you learn what the contribution of each of those is. So by studying the outer planets, we dramatically improve our understanding of space, of Earth. Solar Probe is going to launch in 5 years, so that over its lifetime will tell us a lot about the function of the sun. The electronic age, which we live in, has never seen a solar maximum. There's the sun in 1997. Looks nice and peaceful. Solar minimum. 1998 is getting a little more onerous. And here it is, 1999, and right now it's downright ornery. And 2012 is solar maximum. How will that impact the current set of spacecraft on orbit, the operations of your cell phones, all of the areas that we're so dependent on? We've never seen it. We don't know. So there's a lot we have to learn about the sun and its interaction with the Earth. We heard a little bit about sort of the trauma in the exploration agenda. By 2030, that trauma will be figured out, we hope. And all of these missions, Martian, International, Sample Return, NEO studies, all of these should have been accomplished. And that is a very aggressive, very robust objective. That's exciting. That's really interesting. High power electric propulsion should change our ability to get out of the Earth's gravity well. You know, we live down here, and all of the rockets are just so we can escape the Earth's gravity. You all know this. EP, of course, is the best available. Currently in the exploration portfolio is the development of tugs. Those tugs will increase by more than a factor to what you can take out of Earth orbit, so that we can have Lagrange point, either Sun, Earth, and Earth-Moon facilities at each of these locations. You know, a lot of our observatories are and will be at L2, because one thermal protection can protect you from both the Sun and the Earth. But EP is a big deal. Robotic tours of the Moon, Venus, and near-Earth asteroids by EP tugs will be possible. You can go to more than one place. You know, we've looked at taking a very basic EP system and going out to the moons, to Deimos, sample return, and bring it back. And maybe you'll have a crew member that looks like this, you know. Doesn't have to be. Robots do not need to look like people, and only rarely is there a rationale for them to look like people. Here it was to use tools. But these kind of missions to each of these locations are very doable at 2030. Human exploration of Phobos and Deimos by 2030 is also very possible. Phobos, Deimos, the two moons. Phobos is 7 times more massive than Deimos, but it's a lot closer to the surface. It's deeper into Mars' gravity well, harder to get to. But it has very low density, and so the thought is there's lots of ice reserves in this planet. Deimos this is a D-type asteroid, looks like it. This is a C-type. Both of them are made of carbonaceous material, and this one is readily accessible. So a human visit to Mars moons is very likely, a very likely first human mission to Mars. You're not going to land, but you're going to probably do this in 2030 is the expected date. If you look at the larger space science portfolio, New Horizons is already on the way. 2014 it's supposed to pass. It'll do a flyby, and it's a beautiful mission design. They can fully image both Pluto and Charon, its moon. And by 2030, it will have rendezvoused with some Kuiper Belt object and sent back data on their daylight targets. There'll be missions to Europa, Venus, a Venus balloon atmospheric mission is planned, and Titan, either a surface or a balloon, ideally, and then a Saturn mission. So improved capabilities delivered dramatically improved results. And it's just amazing that that's really good. We've been working a concept called New Worlds Observer, and it has a two-part spacecraft, a telescope. It's to image these little blips that Dr. Jones was talking about, to get a picture of their presence. And this device blocks and it cancels the light of the star, a very particular shape, and this is the image that we're expecting to be able to see with it, so that we can visually confirm the results. New Worlds observer. Vacation in 2030. Here's an option. They say for $200,000 you can do go up quick. Northrop Grumman owns Scale Composites, so we are building this vehicle. It is a new space flight system, and we're trying to keep it that way. No old space fingerprints on it. They have already built their facility. Here's the runway, and this terminal is almost complete. Very impressive. Here you see some of the other systems. SpaceVision Dream Changer, which has the same propulsion rocket as does the Virgin Atlantic, and EAD the space jet. So for $200,000 you can go up and be weightless and come back. Bigelow wants to take that a step further, as actually do these guys, where you can go up for 2 weeks at a time. And they're talking, $10 million, so if you have an extra 10, that would be an interesting trip. So commercial tourism is making daily advances, and you have to be impressed. So, last couple of charts here. How are we doing? We're doing okay. How to succeed on our walk to the future. Well, let's keep it simple and step together. Solve the 4 existence equations when we have a program. Think it through. Build strong teams. I have a group of people, and I've worked with them all my career at Northrop Grumman. And I know each one has a discipline, and if we need to get it done, I know I will get an email at 3 in the morning saying their piece is finished. That they are totally dedicated, and they know their stuff. Nobody can do it all themselves. You need a team wherever you go, and you need to know that they'll back you up. These people are great. Minimize development inside of programs. Don't try to invent it and have it be done by a particular time. Invent it first, and then use what it says. Limit the per development scope. Make it manageable steps. It's very important. Use multiple rapid developments over a single exquisite one. I think these 3 all say the same thing over and over. Promote hardware and software commonality where you can, so you don't have to invent it if you can. Standardize the interfaces, 1553, RS-422. Use them. Employ reusable elements where it's cost effective. Now, when I go and speak at junior highs or wherever, I like to use this illustration because I'm trying to say you should go into engineering. And they'll say, well, what classes do I have to take? And you go through the high school set, and you go through the college set, and everybody on the junior higher goes, boring. Get head damage as they hit their head on the table. And so I use this illustration to say, no one alive can high jump into a second-story window. Something over 7 feet is the limit. But almost everybody can go inside, and if you go up step by step by step, almost everybody can get to the second floor. So as we do that and don't trip, then you will trip, but we don't fatally trip, then we can make amazing progress. Now here's a chart of what I would recommend to my son, anybody. The best, everything in life is about one thing. It's all about relationship. I think you've heard that kind of a couple times. So, if you can get to know a company before your graduation day, all of it. If you can work there, that's even better. They need to know you, you need to know them. So, use your summers, get to study who's around, find out who you're interested in, and make the connection. Now, once you get there, find a mentor and learn who to go to for what. Because half of my value, I like to reach into the ether pull out something that nobody's ever done or doesn't exist. But half of my value to the company is knowing who in the company to go to get a piece of data. So that's your team. So figure out who your team is wherever you go. And then grow to become an expert in a little piece. You're not going to stay there forever, but you want to know that you want to be part of a team where they come to you for launch vehicles or thermal or whatever it is. Work hard, then move toward working a hardware program. So you've brought it from idea to conception. Because you'll learn things amazing that'll help you forever. Then become a generalist. Learn a little bit on the way about what everybody else does so that you can be the cook and pull the ingredients in to make a new recipe. Get to know the customers. Begin that sort of interface, whoever they are. So you know how to present, you know what they're concerned about, you know how to tailor your concepts so they actually will meet their needs. And then move up in responsibility and know when to stop. Know what is the life balance along the way. Don't forget to get married. Don't forget to have children, Because a guy sat me down in my first years and he says, when you're old, it's not going to be your friends or your coworkers who are around you, it's your family. And you want to work so you can have a family, at least that's how I see it. So don't forget that part. Career is important, but it's not going to be the reason you're alive. So 2030 is calling, and it's for you. So answer the call. Thank you very much. I think we have 2 minutes for questions. Anybody have a question? Yes?
I'd like your take on commercial human space flight, other than space tourism. More space tourism.
Okay. Well, I think space tourism is where it's going to start. And you have to check that box before you're going to go further or do more. So it's kind of like a lily pad. So, but anybody else? Question? Yes?
You talked about maybe the militarization of space, possibly.
The militarization? Well, the sad part is, if you're dependent on it, someone is going to want to pull the rug out from under you. So you have to not be offensive, but you have to have defensive systems. So that is important. It's important to have the ability, and so that's why I like proliferated systems. If you have one satellite over one area that does communication, it is too tempting for someone to go kabang and take that system out. But if you have 50 satellites, and if you move one, then a minute later another one comes over, there's not that tendency. It's sort of the opposite of stabilizing. So defensive systems are important, and proliferation is probably the best strategy for all. Yes?
You mentioned proliferation of persistent LEO systems to monitor optical and telecommunications. Do you think that's going to be more driven by the commercial sector or by the governmental sector?
I think you'll see it in both, because commercial development, what generally happens is the government pays for one system. Once you got the formula, then those companies like to proliferate it, and the commercial then makes it affordable, then the government comes in and buys even more of it. So it's very synergistic. Anybody else? Still got a minute? Thank you very much.